In this video we're going to look at solving equations that have logarithms in them. So in other words, you're looking at an equation that's got this log involved with it. Before we get started with this, one of the main things you have to know about logarithms is how you would express a logarithm as in exponential form. So I've got that here for you. In log form, we have log base b of m equals x. That's how we say that, log base b. So the b is down, it's like a subscript and it's tiny, sort of like the opposite of an exponent. That's the base of m equals x. It kind of helps when you say log base b because you're reminding yourself that that's the base. So if you look over here at the equivalent, writing this equivalently in exponential form, b is the base. So this little subscript, when you have your log, that little b, that's going to be your base if you write it in exponential form. And something that always helped me was the saying that the log equals an exponent. The log equals an exponent. The log is always equal to an exponent. So if log base b of m equals x, then x is the exponent. So we have b to the x equals m. And sometimes I write this, let's put this over here. Sometimes I write this on the board the first time I teach it, b to the x equals m. That's how you translate it into exponential form. For example, let's say I had log base 3 of 9 is 2. So if I wanted to write that in exponential form, that would be 3 to the 2 equals 9. And you probably could have figured that out. In order to make that a true statement, you'd have to go 3 to the 2 equals 9. Well, what if you have an equation that has x's in it and you can't, really tell what's supposed to go where? Well, then you have to know how to change this. Let's look at an example. Let's say I've got, how about x equals log base 125, that's a big base, of 5. So to solve this, we want to change it to exponential form. Log base 125. So here's your base. So if we want to change this to exponential form, well, let me do this little green thing. Maybe that'll help some people. 125 to the x equals 5. That's going to be how we write this in exponential form. 125 to the x equals 5. So that's really the first thing you want to do, especially in these little type of problems. We're going to do some other log problems later where there's like adding logs and subtracting logs, and those take a few more steps. But if you've just got a log base something of something equals something and that's it, you want to change it to exponential form first. And we're going to go through some examples where we're going to have the variable where we have it now, then we're going to have the variable in the base, then we're going to have the variable where the m is, and just go through all the different kinds, okay? So key, change it to exponential form. Now, in these problems here, you're going to be able to write these with a similar base. So hopefully you're getting good at knowing, your powers, and you can see that 125 is 5 to the third. That's kind of important. If you didn't see that right off the bat, you have a 5 on the right-hand side, and so the left-hand side needs to be some power of 5 for this to work. We need to get these bases to be the same on both sides. So then you just go figure it out and hopefully come up with 5 to the third. That's the same as 125. And over here we still have 5, or 5 to the first. So then if we multiply these exponents, we get 5 to the 3x equals 5 to the 1. Yeah. And now we're going to use this rule that says if the bases are equal, then the exponents would have to be equal. If 5 to the 3x equals 5 to the 1, then certainly 3x would have to equal 1 in order for those two sides to come out to be the same. And then you just have a little equation to solve. Divide both sides by 3, and x is 1/3. So in other words, 125 to the 1/3 equals 5. Let's think about that for a minute. That's worth talking about. If we were going to check this to make sure we're right, which is always a good idea, 125 to the 1/3 equals 5. Hopefully remember what the 1/3 power means. 1/3 power means cubic root. So we're saying the cubic root of 125 is 5, which is true. So that is correct. 125 to the 1/3 equals 5. So that's our answer. Alright, let me put one up here like this for you to try, and then it'd be a good idea to pause the video and see if you can get it. X equals log, let's go log base 36, that's a 36 of 6. Pause the video, give that a try, and start it when you're ready to check. Alright, so the first thing you want to do is change this to exponential form. 36 to the x equals 6. 36 to the x equals 6. 36 is 6 squared to the x equals 6, which is 6 to the first. Multiply these, so that just gives you 6 to the 2x. And then, so 2x would have to equal 1. Divide both sides by 2, and you get x equals 1/2, and that's your answer. Let's see. Let's try putting the exponent in the base. That could be interesting. Let's do, this one's kind of tricky because it's got a negative in it. That's okay. Log base x of 64 equals -6. First thing, change it to exponential form. What's your base? Correct. It is x. So we're going to go x to the -6 equals 64. Basically, your first step, you're just getting rid of the log. After your first step, the log's gone. It's not really a log problem anymore. It's an exponent problem. So now you've got x to the -6. So that's a negative exponent. You have to remember what negative exponents mean, which mean reciprocals. Negative exponents do not mean negative numbers. They mean reciprocals. So we've got that. Now we've got 1 over x to the 6 equals 64, but we don't really want 1 over x to the 6. We kind of just want x to the 6th. So I can do this deal where if I have a fraction on one side of the equal sign and a fraction on the other, it's a property of proportions. I can flip both sides. So if I flip the left-hand side, I get x to the 6 over 1, which is just x to the 6th. And if I flip the right-hand side, I get 1 over 64. That's the first thing I want to do. Now, I was kind of looking at this step right here. I could have got from our first step, or I guess that would have been our second step, down to here by taking both sides to the -1 power. That's another way to get there. You want to get rid of that negative exponent on your variable. So if I took both sides to the -1, -6 times -1 is 6, and then 64 to the -1 is 64 flipped over. Either way you do it, you want to get to that point where you have a positive variable on your exponent. Well, we're not quite done because we still need to get rid of that 6. We've got x to the 6th equals 1 over 64. How do we get rid of that to the 6th power? What's the opposite of going to the 6th power? It would be taking the 6th root. That will undo a 6th power. So if we take the 6th root of the left-hand side, we need to take the 6th root of the right-hand side. And I'm going to guess, if I'm given a problem like this, that 64 is the 6th root of something. Nice. That's going to be my guess. And you could break out your calculator and see, but I'm pretty sure it's 2. The 6th root of 1 is absolutely 1, because 1 to the 6th power is 1. And so 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. So 2 to the 6th power is 64. There you go. X equals 1/2. So that was kind of a tricky one because we had the negative exponent over here. Alright, it's time for you to try one. Alright, let's have you try this one right here. That just appeared, didn't it? Log base x of 125 equals -2. So pause the video, give it a try. It's always a good way to practice. Alright, here we go. Let's see how you did. We're going to go change it to exponential form, which is x to the -2 equals 1 over 25. So let's do it that other way to get rid of the negative exponent. Let's take both sides to the -1 power just to get rid of this negative exponent. So that gives us x squared on the left-hand side. And to the -1 power means reciprocal. The reciprocal of 1/25 is 25. So now we've got x squared equals 25. We'll take the square root of both sides, which we would usually say is plus or minus 5. But in a log, the base, right here, this base has to be bigger than 0. So we can't have negative bases, so we throw out the negative, and x is just positive 5. Hope that helped. Hope you're doing good on your logs, and we're going to go through some other examples in another video.